Hi, I'm Luke Schlingen, and today we're going to launch your web-based video game with AI. We've had two previous videos, one about getting your portfolio site launched and one about launching your to-do app. This is an extension of those. So there are a few things that I'm not going to dive deeply into, like using a Firestore database or using Firebase authentication, because we've already covered those. And that also includes deploying straight to Cloud Run. But I do want to talk about anything we haven't already talked about, like event sourcing. So today we're going to use a concept called event sourcing, which is a pretty advanced topic, but I want to cover it just because it's pretty critical to what we're about to do with a video game. So event sourcing is a concept where instead of changing something in our database, so in our to-do example, we made a change. We said make video, and then we said make video that is amazing. And when we did that, we made the change in our database, we overwrote it, meaning we replaced the existing value with a new one. What event sourcing does is instead of replacing values, it just adds a history of everything that's happened. So today we're going to make a tic-tac-toe game, or you can adjust that to be whatever turn-based game you want, but I'm going to make a tic-tac-toe game. And essentially every turn is going to go into the database. So we'll say X played in the top right, O played in the middle, X played in the lower right. And that is how everything will be saved into the database. What that allows for is us to go back in time. So if a player wants to undo their move or they want to replay a game, we can do that because we're using event sourcing. So we save every single thing that happens throughout the course of a game. This is actually how a lot of video games work, and that's how you can do things like replay. Even if you didn't have a video camera there recording that thing, you can still replay through everything that happened because you have that list of all of the events. So that's event sourcing, a pretty advanced topic, but something that I think we're ready for. So that is what we are going to use today to build our turn-based video game. The project setup is also the same as the previous labs. Just make sure you have a Google Cloud project and you've got some sort of billing attached to it. And now we can focus on creating our game. Just like the previous examples, I'm going to click this link, which will automatically pop open our description. So here it says we're using a web-based, turn-based tic-tac-toe game. Another thing I want to call out is that we're using simple algorithms like Minmax, and the app should not make any calls to LLMs. In a future video, we'll talk about how to make calls to LLMs from within your app. We'll use Firebase's AI logic for that. But for today, we're just going to stick to making our game and saving those details, those events, into our Firestore database. So let's go ahead and run it. Now, just like in our previous lab, we do want a database for this application. So it says enable Firebase Firestore, and I'm going to click that. All right, the first version of the application is ready. So let's go ahead and test it. It says create and start match. Let's do it. Is it going to, so right away it says missing or insufficient permissions. Now in the previous labs, everything is just sort of worked out of the box, and I haven't had the chance to show you how to fix things when they go wrong in AI Studio. So here is our first chance, and it's just clicking fix. So I click fix, and I'll let it go ahead and fix those missing or insufficient permissions. One thing I do want to call out is the most likely cause of this, because I've done this a couple of times, I know what's happening under the hood, is that Firestore has rules. So as we add a database, we often add restrictions around what we want in the database, who is allowed to put things in the database. And Firestore starts very restrictive, and that is intentional. The rules within AI Studio are designed to be very restrictive, and then if you request changes to your code, it will slowly open up those restrictions. And that is definitely the preference, because you don't want it to be very open-ended and allow anyone to do anything and then have to close the door behind you while people are doing malicious things inside of your database. So instead, Firestore's rules are very restrictive when they're written by AI Studio, and then AI Studio can slowly open them up and allow a few more privileges as we, the developers, say, hey, I need this in order for my app to work. So this is working as intended, and we'll let it run and update the Firestore rules until we are able to use the app as expected. Looking at the result, I think I was right because it said it updated the Firestore rules to grant permissions for creating and synchronizing match documents and append-only event subcollections for both Google authenticated users and guest players. So because I haven't signed in with Google yet, I'm assuming that I am a guest player when I click create and start match. So I'll say create and start match. And now I get the first move. I'll go in the top left corner and the Minmax engine has decided to go in the middle. I'll go in the lower right and block that. And let's see, I need to block this. I almost missed it. And there we go. The game ended in a draw. Now, if you know how to play tic-tac-toe, that's probably how it'll go most of the time. But what I want to show is down here. Yes, it did create this feature. I didn't actually know until I scrolled down. So I'm glad it did because I started my sentence as if it would. So I can step back and I can see the replay of what happened. Now, obviously, tic-tac-toe is maybe not the most exciting example of this, but in your use of this lab, you can change tic-tac-toe to a different game. Maybe you can make it chess, or you could decide to do a completely different game. Maybe you want to make up your own game. So now that we have this game built, I'm going to click publish and say get started. And let's publish this app. So it says tic-tac-toe 8103. My guess is that tic-tac-toe is already taken. So I'm going to say Luke's tic-tac-toe. Again, you can change this as long as it is unique, as long as you're the first person to get to it, you can get that .ai.studio domain. So let's publish the app. Tic-tac-toe is published. Let's go ahead and visit that application. And here we are. It is up and working. One thing I haven't shown previously, but I want to show with this application because I think it's a cool and important part of using Firestore is since we have the real-time sync, we can play these multiplayer games and we don't need to build in any synchronization. It's already done for us. Because this is deployed live to Cloud Run, I can play across different devices. Now, I have one device here, but I've logged in on 2 different accounts and I'm going to test out the online multiplayer mode that it has. So let's create and start a match. And now I've got a code here that I can copy. It also says copy share link. So I wonder if I just go over to this tab and paste it, if I get directed straight to the game, and it does. So it says guest player and it says Luke. It does seem to be the same game. Let's see what happens when I click the top right over here. It says it's the other player's turn. Okay, let's click here. Okay, so it's decided that this is the guest player. So we've got the host over here, who's the one who created the game, and the guest player is this yellow, this dark mode browser here. Player O doesn't seem to be able to go. Okay, so this is a bug that I'm noticing. This bug, because I didn't catch it before I deployed, is a bug in production. So I will go back to AI Studio and say the invited guest is unable to play. The error says, and then I'll copy the error directly. And the reason I will copy the exact error is that will make it easier for AI Studio to find that in the source code. AI Studio has finished its debugging and has found what it believes to be the solution. So let's test it out. I'm going to republish my application. So I'll say republish online multiplayer, create and start match. I'll copy the share link. I'll paste it over here. Player on the left, player on the right. It says it's X's turn, and it makes sense that the player on the right wouldn't be able to play. I'm clicking right now, and it's not doing anything. But now if I come over here, can this player move? Yes. All right, what about over here? Can this player move? Last time, this is where things broke. Yes. Okay, so now we are finally playing tic-tac-toe. So I'm going to play both sides of this. I'll play there, and now X has to play here, and I think this means we're at a cats game. So I'll play X here, but now I have a multiplayer version of tic-tac-toe that is live and shareable. And if you have a game that you've been thinking of for a while, you should now have the tools that you need in order to build it. Share it with your friends. You can play against each other online in real time. That's the Firestore thing I wanted to show off here, is that even though it's happening on this side of the screen, it's updating on this side of the screen. And that's not only true because it's on my computer, it would work even if this was 2 separate players on completely different continents. So that is what's so exciting about using that functionality. So that is launching our turn-based video game in AI Studio build mode. So let's see if there are any other steps as we wrap up. Test and iterate. We finally got to show that off because something went wrong, so we were able to fix it. Deploy to Cloud Run. We did that. We not only did that once, but we did it twice after we made our fix. And then inspect in the Firebase console. We did that in the previous episode, but I do want to do it right now as well because we're going to see something different. So the reason I wanted to show this is because I wanted to show exactly how this works. So I have games, yes, but within my games collection, I also have events. And these are the events that I was talking about earlier. It says sequence, so that was which turn was it? And then it sorts by those. And as those are sorted, we can figure out, okay, so what is the actual state of the game? And it uses the history of all of these events to decide what is the current state of the game. So it knows all of the places that were played. It knows when somebody played there. And so this is the type. So this is that event sourcing. Again, not something you need to dig too deeply into, but if you want to create a video game, this structures your game in such a way that you can do the rewind and you can do the replay and all of that fun stuff. So a solid foundation for your web-based video game. As always, feel free to clean up your project if you'd like to take it down and you don't want it to be available for the world to try out. And you can wrap things up here in the conclusion. If you do get this far, make sure you visit this link to claim your completed Builder's Badge to show us that you've done this lab and you were successful. Thank you so much and happy building.